Hi, my name is Krishna, and today I'm going to be talking to you about building a PaaS using open source software. So over the past year or so, we have been working on trying to get OpenShift, which is the Red Hat's PaaS software, to a point where it is a world-class service. Right? And we being Red Hat, we have tried to release as much as possible of this software out into the community. But this has presented us with some very interesting challenges. When releasing OpenShift, there were many moving parts, and all of these pieces needed to be packaged properly. But what we have right now out on GitHub is a project named OpenShift Origin. It's our belief as part of Red Hat that this is a very important step as far as open source PaaS software goes. And up till now, we have been relying mostly on user feedback to improve the quality of our software. But now that OpenShift Origin is out there, we are hoping to expand the power of the community and have them influence and interact with the software, submit pull requests, and improve the software as well. But really, this is just the beginning. As with any open source software, the community needs to play a major part in improving it, providing us with feedback, and taking part in the software. So let's start by doing a level set, make sure that everyone's on the same page. Right? There is a common misconception there's a common confusion between what an infrastructure as a service is and what a platform as a service is. So this is basically rule number one. And infrastructure as a service is not the same as platform as a service. Infrastructure as a service concentrates more on virtual machines, whereas platform as a service is more a concentration or a focus on applications. Right? And the second rule is that PaaS is not a silver bullet. It does not solve all your problems for you. It is a very useful tool, but it targets a subset of all of the problems out there. Right? It's great for self-service environments where you have your developers trying to quickly bring up a application and they want to try it out. It's great for varied and volatile workloads, and this is basically when you need a stage environment or an integration environment for a couple of days. You can quickly spin up a service there, have your application running, test against it, and then shut it down when you don't need it. It also works great for instances where you have spikes in load. So for Christmas shopping, you want your web app to scale up to 100 gears and then scale down later. That's great and works well in a PaaS. Another very useful thing a PaaS provides is a polyglot environment. It's basically where you have multiple languages being supported on the same system. And even though there are multiple languages there, they all follow a very standard deployment model. Okay, so the next rule, a PaaS is about developers, but it is also about operations. And it's really there not to speed up the development effort, but to provide a way for development and operations to have a common language to talk with each other. But it's not really a walk in the park. A PaaS is new software that's coming in. You do have to spend some effort to learn what's going on. So it is very important to be ready to learn this new technology that's coming out. So let's look at what developers want. Developers are interested in having their choice of language, so they want Java, Node.js, PHP all available to them. They want the application to scale up and down automatically and on demand. They want the platform to be extensible so that they can add in pieces that are missing. And they're also interested in getting continuous integration working. So this is basically whenever they push code, they want it to run all the tests, and only once all the tests have passed to deploy the code. Operations, on the other hand, are interested in a slightly different set of metrics. So they want the platform to be multi-tenant. They want to be able to use the full capability of the hardware that they have and not really just and not leave any idle space behind. They also want the installation to be easy and familiar and repeatable, and they want the configuration options to be sane. This is actually a place where PaaS fits in very nicely because PaaS provides a multi-tenant platform. So you may be wondering, what exactly is multi-tenancy? Don't I already have that with virtual machines? And this is really an analogy. It shows you, in your office, you basically have a whole bunch of machines, and all of these machines have many virtual machines running within them. But really, they are drastically underutilized because each virtual machine is running its own copy of the operating system, and the application under it, you have to leave some space for it to scale up and down, which generally doesn't make the platform very well. So if multiple applications have to scale up and down, you're leaving a lot of empty space behind. Right? And it's also hard to maintain because if you need to apply patches, now you have to go through and apply it to every single virtual machine. It's not just a one-time thing. Multi-tenancy, on the other hand, is something similar to this card, where you have many different applications running on the same hardware. And you only have one operating system. Patching is extremely easy. You apply it once and it's applied to all applications. And this is especially good when you have a whole bunch of small applications that are not being used all the time. So if one application needs to scale up, it can use the spare space that's left by the others.